transform. Laplace transform. Laplace is the name of the inventor. What we have to discuss is about transform. What we have to discuss is about transform. There are different types of transforms. We have a lot of transforms. Z transform, Fourier transform, Laplace transform. Even in Fourier transform, we have finite, infinite, sine transform, cosine transform. Lot of transforms are there. The fundamental, the simplest transform what we have in engineering is Laplace transform. What we have in engineering is Laplace transform. Again, why Laplace transform? Why Laplace gave the concept of Laplace transform? In those periods, there was a situation where complex problems were tedious to solve. So at that scenario, Laplace was the person who gave an idea to reduce complex forms into simple forms. So Laplace transform can be used as a tool. For example, logarithm. Have you heard about logarithm book? Have you heard logarithm book we had for 12th standard even for physics and all using table values for? Am I right? In a lab at all. So logarithm is a concept to simplify complex problems. How? Suppose if you have a very big decimal value, two decimal values, you have to multiply two decimal values with 0.0578. Okay, so what we do, we take the log of both the values and we will add. We will get some answer. For that we will take anti-log. We will get the result. So that was a tool. Olden days we were using logarithm. Instead of calculator, we can get the result. So similarly, if you want to divide two decimals, what we do? We take the log of two values, we subtract and we get the result. For that we see anti-log. Similarly, in engineering problems, we can use Laplace transform. We can simplify the complex equations to different domain. Then we use inverse Laplace transform. We use inverse Laplace transform to retrieve the results. This was the idea behind. So Laplace transform actually works as a transformer. Suppose in our near to our home we have a transformer, electrical transformer. It reduces or it transforms the current voltage. Am I right? So from higher to lower. So because our home appliances, it will be working in 240 volt, for example. So for that we have to reduce the powers. Am I right? Because the current coming, the force, the voltage, the current comes from the maybe from the powerhouse or somewhere. It will be of huge voltage. So our transformer near to our home, it will reduce to according to our home appliances. Similarly, in engineering, for example, even for differential equations, see, you know, in first semester you saw various types of differential equations. In school level, you saw various levels of differential equations. School level, we are using separation, variable separable method, homogeneous equation models. Now, in this first semester, we were using Cauchy's type. So, there are different types of differential equations. Even to solve the differential equations, we can use Laplace transform. That is in mathematical field and also in mechanical field, also in electrical field, we have come across various differential equations. In order to solve, to simplify the differential equation, we can use Laplace transform number one. Suppose if you take communication department, suppose communication engineering for example, we will be dealing with signals. Am I right? It is dealing with signals. So one man is talking in a phone, that is, he is talking to a person, there is another person who wants to receive the call. The voice with which he talks has to be similarly to the voice which he hears. Am I right? There should not be any disturbance. So in order to reduce the disturbance, in order to filter the noise, in order to filter the noise from the transmitted signal, you know, our voice is converted into digital signal, that is what is sent to that, and the wireless phones what we receive. So in that, again in programming, they use the concept of Laplace transform, they use the concept of Fourier transform, likewise several transforms according to the different types of signal, because we have various types of signals, sinusoidal, because then the turbulent signals are there, streamlined and many types of signals are there. So according to the particular signal, we'll be using the right transformer to reduce the noise and to get a proper output. Okay.